Okay, today we're doing representations of relations. First, let's start off with this table. We need to talk about what domain and range is. So the domain is all the x values of the function, or for this purpose, this table. So we're just literally going to list out all of the x values that are on this table. So we got 3, -2, 0, and if you notice, a 3 happens again. So on your domain, we are not going to repeat numbers because you already have listed out the number 3. So we don't have to list that out again. And that's it for domain. Range. Range is all the y values. So again, we are literally listing out all the y values that you see. So on this table, we have 1, -4, 2, and 6. We have 4 items in our range and only 3 on our domain. And the only reason why there's a different number of items in each one is because this 3 repeated. Now, let's talk about function. Is this a function or is this not a function? In middle school, you guys went over function and non-function, and you should have learned that if an x repeats, like this 3 right here, the y value has to be the same. So whenever you choose 3 on your x, the y value that comes out has to be the same. If this is 1 here, then this 3 better give a 1. It didn't. It gave a 6. So this is not a function. All right, let's go over to ordered pairs. In ordered pairs, they give us 3 ordered pairs. We got -1, 2, we got 0, 5, and 2, 7. So again, domain, all the x values. An x value for an ordered pair happens first inside the ordered pair. So we got -1, 0, and 2. And range is our y value. So here we got a 2, a 5, and 7. None of them repeated inside of our range, and none of them repeated inside our domain, so we have 3 items in each. Is this a function? Well, like I said before, if there's an x value that repeats, then we have to check to see if the y value is the same in both. But since none of the x is repeated, this is automatically a function. Now, next is our graphs. Here we have a graph of a circle. Let's talk about domain and range. Since domain is all of the x values and this is a graph, we have to go from the least x value that we can get to. So it looks like it's going to be -1, -2, -3, -4. After -4, there is no more line that goes right there. So here's our very smallest x value that we can use. And if we use the highest x value that we can go is this +1. Now, if you notice, there is no actual numbers here, it's just a line. These other 2 that we talked about, the order pairs and the tables, they had numbers shown. These are called discrete graphs or relations. Discrete relations have to give you actual numbers. So this 3, the -2, the 0, -1, the 0, the 2, those are discrete because they give you actual numbers. The graph does not. It gives you a line of infinite values. The only numbers that we are, the only numbers that we really care about is this -4 and this 1 for the domain, because those are your boundaries. That's the least number that we can get to on the domain for the x's, and the biggest number that we can get for an x is a 1. So there's an infinite number in between this -4 and this 1. So this is how we're going to write this. Since this is a domain and this deals with x values, we're going to put this x in the middle, and we're going to put the lowest boundary, which is a -4, and we're going to put the highest one, which is a 1, all the way over here. And we use inequalities to say that there is an infinite number of numbers in between -4 and 1. So that's how we write our domain. Now, for the range, we're going to do the exact same thing, except range is dealing with y variables. So we're going to look at this graph and going to go all the way down to the bottom of the graph and see what value is our lowest boundary. So for the y values, we got -1, -2. This graph goes all the way down to -2. And for the highest value of y, we have 1, 2, 3. 3 is our highest value for y. So again, since this is a continuous graph and it has infinite number of values in between -2 and 3, we have to use inequalities to say that there's a bunch of numbers that are in between these that are part of the range. Now for function and non-function, if you remember from middle school, there's a test that you can do for graphs, and that's the vertical line test. If you place a vertical line through a graph and it hits more than once, which it does here and here, then this is not a function. Now, for mappings and equations, mappings are going to be discrete because it gives you actual numbers to use. An equation is going to be continuous because it doesn't give you an actual number. It gives you a range of numbers or an infinite amount of numbers. And we'll talk about this a little bit more in detail in class.